Good day, everyone. Today, we're very pleased to present Mingyu Ma. He is a PhD researcher at the Dresden University of Technology in Germany. His focus is computer networks, programmable data planes, and simulation platforms. He's been actively involved in bridging the gap between research prototypes and real-world deployments with hands-on experience in P4, ns-3, and traffic control. He regularly contributes to academic conferences and open source communities related to network systems and simulation. So please take it away, Ming Yu.
Okay, thank you for introduction. So I will begin my presentation for the P4sim protocol independent packet processors in ns-3. So let's start with that topic. So first I will introduce the motivation about the P4 programming protocol independent packet processors is a domain-specific language for program protocol independent packet forwarding, and assume that we have a P4 code for control the switching, and then the developer will deploy with the P4 programmable data plan target, and then it will build a new switch in complication time. So that's very powerful and advantages. Have many advantages. It enables rapid adoption, provides fine-grained control, and also improves the flexibility and scalability. So for summary, in the last maybe 5 or 10 years, people have received widespread attention in the network community. It accelerates the evolution of the networks. It has achieved many things in the computer networks. That makes that means that P4 makes the network better in network computing or congestion control or load balancing or network environment areas. So another thing is that ns-3 as a discrete event network simulator, it's also widely used for the researching and education. It enables realistic simulation of wired and wireless networks. It's supporting detailed performance evaluation and reproducible experimentation. So what if we bring the P4 into ns-3 as a mode? So that's our motivation and also the target. A brief, this page I will show you the content of this talk. So later I will show the related work I've done in the ns-3 and also P4. And then I will introduce how I designed the P4sim and how implemented that. And then a small evaluation. And then I talk 3 or 4 use cases. And then at the final, I will talk to the conclusion and the future work. So first, I will talk the related work. So as we all know that there are many targets or platform for P4, like Tofino, NetApp PC or SmartNIC, and Tapas BNV2, and our designed P4sim. So they have different use cases, and like hardware usually used for productive level deployment or acceleration. The emulation, it's with high performance processing, but it also depends somehow with hardware. For the simulation, it's efficient and independent with the hardware, and also scalable and reproducible. So that's our. Then I will talk our goal for the P4sim to produce a more practical, complete, and accurate P4 simulation framework by integrating P4 behavior model into ns-3 and enable scalable, cost-effective, and reproducible protocol design exploration. After we talk the goal, I will talk about before there are some integration attempts in the ns-3. So I will describe them, and also talk about the limitations of that works. Like I have listed all the 3 related works. So like the net devices it first generated C code with topaz compare, and then it compiles all the binary code alongside the ns-3 simulation code. So the limitation will be it's very hard to build the code and also low modularity and traceability. For the second ns-3 BMV2, this particularly integrates the BMV2 into the ns-3 traffic control module. So it means that it can only doing the work with traffic control. So not like a forwarding or routing or time-aware modeling. And there is also no event drive. So there is no simulation time in that. And for the last one, ns-4, it also integrates the BMV2 into the bridge net device. But it's also missing some part like the queuing, time-aware modeling, and also not event-driven in S3. So also it's unable to implement protocol-independent features, like if user modified packet headers, so that cannot do in NS4. So that there really are some limitations in that. So we decided to extend this module and then build a new module to enhance that. After that, I will show the overview of the P4sim. So it will have the high performance event scheduling with the P4sim, P4 switch, and also the queue scheduling. And second, it extended P4 support with 3 architectures, and also it's use protocol independent design, enables P4 custom header in ns-3, and the last seamlessly integration into ns-3. So let's talk about the modeling in the switching part. So there is a figure shows that we have divided the P4 switch in 2 areas, like the control plane and also the data plane. So usually we focusing on the data path. If the host send a packet to the switch will processing that with the P4 processing pipeline, and then go forward to another switch or host. This is the data path and also the control path. Here is we can build the controller in the ns-3 as a host, and then it can connect it with all the switches in the network, and also configure the switches in the runtime or in the start time. So that's the overview of that. The design, we use the bridge net device in S3 and include the external BMV2 behavior model, like the parsing or match action, this area, and then extended with like the before open flow done in the ns-3 simulator. So we have listed the hardware management part, which is configured by ns-3, like the port or switch architecture or related configure or buffer in the switching or the switch rate configuration, like a packet per second or something. This is the hardware management. This is configured with ns-3 script. And also we have the programmable switching part, which is configured by the P4 or script or flow table entrance. So this can be, this is the P4 configure. So with these 2 configures, we can configure a switch devices and testing in the ns-3. Then I will talk a little about the buffers. Like we have the input buffer or queue buffers in the switch. And also we include the BMV2's packet metadata, and also the packet processing register. We have, because ns-3, we need to integrate it into ns-3. So we added the ns-3 address or ns protocol for running in ns-3. So, and also the external action add-ons like this for the switch. After that, talking about the whole design, overview of the design, and also the buffer management or some hardware management. We will talk about the queue buffering or watch time alignment. So first NQ, we will base the type of service or priority allocation. This can be defined in the P4 or the table entrance, and then set the expected DQ time for the unqueued packets. This is determined by the switching processing rate, like how many PPS it can be reached. And then the DQ, we will use the PFI first in, first out, priority first in, first out queues in the switch. And then we added the expected DQ time for the packets to like the token token buffer or something to limit the queue rate, and then it will achieve the queuing scheduling and also the watch time, because it makes the time forwarding in the discrete event simulation in S3. So the scheduling, we use the polling mode, and based on the switch processing rate, we set the events of each DQ event, and that makes time forwarding in S3. And after that, we will talk about the P4 architectures supported in the P4sim. First is the V1 model, the simple standardized description of BMV2 forwarding pipeline. And then the PNA, portable NIC architecture, and also the PSA, which is a little complex, more like a single switch. After that, I will talk about the protocol independent design part in NS3. Currently, we have the switch with the protocol independent design. We also need the host in NS3, like the sender or receiver, to support the custom header format, because we need to send some traffic to test in the switch. So it's very straightforward for this design. So I just define the layers. The host and the receiver want to send the packets, like to add the custom header. They can add before or add after, or replace some header part of the packets. After that, the host, like sender or receiver, will insert the custom header into these different layers, and also to receive that. So all that things makes the sender and receiver side to process the header correctly, can receive the packets and not have some bad effect with the upper layer. So we can also use, yeah. So that's the design idea of that. And then I will more briefly, more exactly explain that. So if we have that packet want to send in the network stack, we will add the custom header in that, and then send out. We will also check the Ethernet tab or next protocol, this field of the header, to make that it can be parsing or deparsing correctly. After that, it will send out. Then go to the P4 switch and processing, like with custom header. And then after the receiver side will automatically deparsing and go to the up layer, like the networks layer or application layer, or even to the higher layer. So that design, the upper layer applications like on-off application in NS3 remain unaware of the custom header. So it allowing us to maximize reuse of the existing applications, because NS3 already have many modules, like wireless module or wired module with some applications. They can generate the traffic with some different tabs. So we want to maximize reuse the applications. After we talking about the design ideas, I will show exactly the implementation of the like a PSA module in S3. That may a little complex for that, but I will try to describe it briefly. So this is the original PSA module in behavior model. So like a input buffer, ingress, traffic manager, and the egress depassing something. So this is also the primitive actions in the behavior model. We also ported into the S3. And then we added some switch configuration, like hardware configure in S3, like the buffer config switch rate depends on decides the scheduling rate, and also the port management of the input or output, and also the input buffer. And also we added the P4 configurations with like the hazard graph, control program, or action set. This is compiled by the P4, and also the table configurations. So that's the totally design of the PSA module in S3. So that are two key aspects: the buffer management scheduling in S3, and also the packet forwarding pipeline configured by the P4. So similarly, we also deployed the V1 model and the PNA. So after the implementation, we'll have some briefly evaluation, like the goals of this tasks is like a high performance scheduling, P4 support, protocol independent design, and seamless integration with ns-3. So our scope is that we have one evaluation for performance and design effectiveness, and also list the 3 use cases to show the extended P4 support and protocol independent design. The evaluation matrix is forwarding throughput with the IPv4 forwarding, and also the simulation execution time to that can measure the design effectiveness. So we compare the P4sim switch with the ns-3 bridge, which is the switching part in original ns-3 simulator, and also the minet with BMV2 switch with the IPv4 forwarding scenario. So we can see that we have tested the input throughput from the 1 Mbps to the 10 Gbps, and the output for this is the output throughput from the switch. Also, this is measured in the receive side. This is measured in the sender side. So we can see with the increased the sender throughput, the output of the minet will have a bottleneck. It cannot achieve very high performance. But the ns-3 and P4sim, like simulation, can achieve very high performance, even in a very in a virtual machine with not too much high performance CPU or memory. And also we measure the execution time, like how if we simulation 1 second in the simulation time, how many real time we will use. And we compare the S3 bridge original switching part and also the P4sim, our design use the same area IPv4 forwarding. So we can see that the P4sim use much time than the S3. As we measured, like 10 Gbps, it will use the 3 times much more time than the S3 original forwarding scenario. That means it's also acceptable for the simulation. Just the 3 times may, but it can run the programmable switch in S3. So I will talk about the 3 use cases. First is easy to simulate the large scale network. Like we set a scenario with factory. So like we set the parameter in the S3 script, and then the S3 will automatically generate the network topology, like total 45 switches with the core aggregation H, and also some servers for testing. Like this, yeah, this is the core aggregation and the H layer, and also the server, some servers. Then the script will automatically generate the flow table entrance for each switch. This I have set the IPv4 forwarding, and then it will automatically generate the flow table entrance for the ARP and also IPv4 entrance. And then the user can easily start the simulation. So we have tested a 2-second simulation. We use maybe 1 minute real time with this hardware settings. Yeah, it's very easy to use and do the simulation. And we also, another use cases is the load balancing with the P4 register and the hashing. So we set a very simple topo and also the configuration of the links and the traffic pattern. We use the 1000 UDP flows, like applications in there and also there. So, and also each flow rate be 0 bits to 10 megabps. Total peak load will be 10 gigabps. So the result is we have achieved the nearly equal traffic distribution. So we have the path A and path B. So I marked the path A with this blue, and also path B traffic with the deep blue. So we can see that the input traffic will be with a red mark like this, and it's almost half divided by the two paths. So we have achieved. This is just a simple demo for the half hashing for the traffic, like confirm the efficiency of the hash-based ECMP strategy with that traffic. It achieved the high performance with event scheduling and also extended P4 support. We have the second use cases, it's tunneling with custom headers. So we set up the custom headers in the P4 script, which will define the processing pipeline in the switch, these 3 switches, and also the ns-3 script to define into the host of the sender and the receiver side. So this is in C program in the ns-3 script. Briefly set the field of the value to send, and also that will also tell the receiver how to receive. If normal traffic will be transferred by through the S1 to S3 and then to the S2. If we detected the tunneling headers, it will forward in between the S1 and the S2 directly, like the tunnel packets. So with that design, yeah, this test successfully, and then we capture with the PCP file, and then use the Wireshark to analyze the headers. We can see some different things, like the Ethernet headers in the simulation, and also the ETH protocol, which are as defined, and also the protocol ID, the destination ID, and the IPv4 headers. As we before said, we insert these headers into the switch part and also modify the protocol type and also the next like the protocol ID. This is for the last parsing part. and it successfully supports the protocol independent design. So after the briefly say the three use cases, also there are some other examples and also the parameters to control or simulation for the P4 switch. Listed in there. This also in the GitHub, like the tracing or sweeping or architecture, JSON path or floatable path or other things. And we also have the examples, some examples like tunneling, firewall, forwarding, load balancing, and also QoS. This is for testing the priority and also the queue buffering in the S3. Also the simple PSA. So most of the examples is from the Viva model and also from the P4 tutorials. And then I just transfer that easily to the ns-3. So after I show you all the design, implementation, and also evaluation with the performance and also the use cases, I will draw the conclusion of this topic and also the future work of that P4sim. So it's an enhanced P4-driven simulation framework with high speed and large scale programmable data plan networks. Extended P4 support with Viva model and the other architectures, and also protocol independent design for the S3, seamlessly integration external modules from BMI2 into S3. So the evaluation shows the efficiency, precision in packet processing and queue management, and also improves the simulation fidelity and scalability. And the future work, it should be the integration, the link state awareness. Currently, if some link in between the switches or the host be congested, actually the switch currently not very aware of that part. It may not can efficiently control the congestion of the link, and also the more use cases and the examples for this. I think that's all, and this is my reference for this work. Thanks for your listening.
Thanks, Mingyu. We have some questions coming in chat. If folks have any other questions, please do enter them in chat. I may call on you if you want to, if I get, looks like you might be best if you ask the question, but I had one starting question or high level overview. Just, I have for several years now kind of watched public forums and issues on P4Lang GitHub repositories, and maybe once or twice a year, someone comes in and says, I downloaded BMV2, I compiled this P4 program. I was trying to, do TCP congestion control modifications, or I was trying to do, things that build up queues in the network and wanted to get, ECN marking modeled and things like that. And very often they'll run into situations where they'll send high rates of traffic and BMV2 unmodified without P4sim will, build up long queues at weird times because it's not trying to, I mean, it's not really meant to be a performance simulation, accurate performance simulation. It's just a software switch with its own set of queues and very simple scheduling, and it, can build up queues at unusual times that a real switch wouldn't. So my high level understanding of your work is you get to program in P4, but all the enqueuing and dequeuing and packet transmission events are now carefully controlled in ns-3 by their when they get transmitted on a link or when they're enqueued and dequeued. And so therefore if you do it really high loads, it will not run at real time rate. As you mentioned, like 2 seconds of network simulation time might take several minutes with lots of packets. But at the end, you get realistic performance data for what would happen if you were running this on real hardware. Is that maybe a fair summary of the benefits of P4sim? Just more accurate performance simulations?
Yes. So while running the emulation with the BMV2, I find it's with a single host. Sometimes if the traffic is very high, it cannot processing that packets in time, so it will maybe drop the packets.
Hmm.
With the P4sim, with the virtual time, so it can reach the performance as you wanted performance or scheduling or the rate of the switches. Yeah, exactly with the simulation time. And that you will not have the problem with the performance limit.
Yep. So let's see. We have a question from, I will probably mispronounce names here, Aristide Akam. He says, interesting work. Uh, to what would you attribute the improved performance of P4sim over Mininet, assuming that the simulation or emulation is on the same host in both cases? I think you showed a graph that seemed to show that P4sim would achieve higher packet processing rates than Mininet, if I'm remembering correctly.
Uh,
Yeah, I think this was
yes,
one of those charts. So it is what you're showing here that if you run ns-3, you're comparing ns-3 without P4sim against P4sim. Is that the comparison?
yes. S3 because S3 originally have the bridge module, they don't have the switch module. So I
Oh,
just compare with that.
actually, maybe it's the one on the right that he's asking about. Mininet with BMV2 switch is the one on the right you're comparing against,
Yes, the MINET with BRV2. This is that the
right?
yellow.
And so when you say that P4sim is getting higher performance, is that higher real-time performance of number of packets
Not real
processed?
time,
Okay,
not
this
real
is
time,
okay, this
virtual
is
time.
virtual time.
Yes,
Okay. So the actual wall clock elapsed time on the server might be longer.
yes,
Okay.
exactly.
Okay. All right. Uh, Aristide, if that answers your question, great. If otherwise, feel free to follow up with if you want to even unmute and ask a question
Yeah,
right now to follow up, that'd be great.
yeah. Thank you, Andy, and thank you, Ming. So I think that answers part of the question, and also the discussion you had before reading my question also contributes to that. Given that when you're running P4sim, like you said, the BMV2 switch now uses the queuing of that is already optimized in ns-3, and so I guess that could contribute to the improvement we are seeing. So I think that kind of contributes to answering the question. So I think that's fine.
Uh, I mean this Q part.
Yeah, so you mentioned that so when you're running in P4sim, the
Hmm.
queuing is not, so if you're running BMV between or V1 model switch in P4sim, then it's no longer going to use the queuing of BMV2, right? So it's going to use that of P4sim, which is which is based on ns-3, and in that case it will be more optimized. Is that correct?
Yes, we rewrite the Q name in S3,
Yeah,
but
yeah,
the
yeah.
behavior is the same with the BMV2 because
Oh,
at that time I think the BMV2 it means the behavior model. So I
mm-hmm,
just based on that behavior, like tuning in
mm-hmm,
BMV2, I write the
yeah,
that into the S3. So for the behavior of that two queues in the two
yeah.
platform should be same.
Be the same. Okay, thank you. Then just since I'm already unmuted, let me just ask the last question I had.
Please.
Uh, because you said there are some slight modifications you make to the architecture, no? For example, you showed for PSA, I think, if I'm not mistaken, or yeah.
Yeah,
So do you do have some modifications in the compiler as well, or do you use the same P4C compiler for your
you use
P4
the
code?
P4C.
Okay, you don't have any. Okay, thank you.
American.
Yeah. So in general, it sounds like, for example, I know there's been some work on PSA and BMV2, but right now, today, my understanding is the V1 model is much more mature, is the best, longest supported one for P4C and BMV2. So let's focus. I'll focus on V1 model just because I think it's the the most mature
Yeah,
support of the open source. So somebody should be able to write pretty much whichever V1 model program they want, and if they can compile it and run it on BMV2 without P4sim, they should be able to compile and run it the same way with P4sim. Is that true?
yes.
You shouldn't need to make any changes or okay, good. That's great to hear. Um, Another question we have from Reza Falahi. Reza, if you want to unmute yourself and ask the questions live, please go ahead. Otherwise, I'll ask them.
Uh, Hello, everyone, and thank you. Yes, I have just simple questions about the first one is about the controller and the control plane, and it's about how the P4sim module actually works. So, do we have some kind of advanced applications acting as a controller, or is it just simple forwarding rules being installed on the switches? I was just wondering, and if there are actually ways to develop more advanced applications for the controller. For example, we've been working with the ONUS applications. We have more flexibility in terms of developing those applications on SDN. I was wondering if we do have this kind of features in this.
Currently, the P4 controller is basically can show print the flow tables of P4 settings in that, and we also add some callback functions. These callback functions, the users can use that to insert their own functions in the controller, and that allows the user to modify some table actions. Sorry, like modify some tables or entrance in the running time. So currently we only have maybe 2 examples for that, but I didn't list in there because it's still testing. Now it can very well working with the insert action and also the print the flow table entrance. So this part is not very completed finish.
Very well, very well. So, can we consider quickly, just simple, can we consider this as a, I don't know, top level kind of controller applications, or is it just the simple examples that you said? Is it that kind of
Simple.
mature to depend on?
Uh,
Or maybe I could try to add another question. You're familiar with the P4lang tutorials repository, Mingyu? I think you've
Uh,
used some examples from there.
like P4
yes, of
tutorials.
course.
Yeah. You're familiar with that tutorials repository and some of the exercises in there?
Yes.
And they
Yes.
tend to write small control. Some of them have no controller program at all. Some of them have a simple
Exactly.
controller program written in Python that uses the P4 runtime API control protocol between them and switches.
Yes.
Does P4sim support if somebody wanted to write a Python program and use P4 runtime API to add and remove and delete table entries during a run, is that supported in P4sim as well? To use
Yes, it
P4
should
runtime
be
API?
support. Yes,
Okay.
we also that APIs into the P4 controller, which is another
Okay.
module
You
in
haven't removed
S3.
that support in P4sim. That's still there. So somebody can write their own programs in any language if they want to control.
Yes. Yeah.
Okay, okay. Thank you very much. And just quickly, which version of the ns-3 have you used or tested? Of course, I've tested with the version 3.45 and it wasn't compatible with the P4sim module. I was wondering which version is the latest compatible one.
For me, I think I just test with two variants. Sorry.
Okay, thank you very much. Thank you for that.
I think okay. 3.35 with the WRF build and also the CMake build with 3.39. So it can be, but it cannot compare with the C++20. So that means you cannot use the C++20.
So let's see. I believe so. We have some other questions by. I'll ask one of them live myself here, and then let him, if he wants to ask the others. So P4sim is, I believe, open source, and you've got a GitHub repository link somewhere in your talk, I believe.
Yes, at the beginning and also the end of the talk. Yeah. So here I have the QR code onto the link.
Great. And yep, so I think several people would probably, I'm guessing, might like to try following up and try downloading and installing and trying it out on their own systems to see. So yeah, it just don't be surprised if you get a few questions on how to install it or how to set things up. So the clearer your README instructions are, the less questions you'll get. But hopefully there's some first hello world example, kind of starter example that is in that repository. It would be nice. Sorry, I haven't tried it yet myself, but I would like to.
Okay.
Dulasi Vegalam, would you like to unmute and ask any of your questions besides the first one?
Yes, certainly. Thanks for that. And the question is it possible to use multiple P4 instances as multiple switches? Like in your diagram, you have a P4sim switch and there are two hosts communicating via that switch. So instead, can we have two P4 multiple, like two P4sim switches communicating each other? That's possible.
Yes, each switches can be configured with different P4 script and also flow table entries.
Okay. Okay. Yeah, thank you. And one other question. So why the P4sim built specifically on ns-3 rather than any other simulator like Mininet or P4 Studio? Any particular reason, or it's just a research question you have taken?
Actually, the Mininet already have the BMV2 switch like support, and there is no other big issues or limitations, so I didn't build in Mininet. And for the ns-3, actually, it's because before I have testing the Wi-Fi using the Wi-Fi module in ns-3, I found it's very well, like a very good simulator, and also it have wired and wireless, of course, any other modules, and are very popular in this I say the research areas. So I'm most interested in the ns-3 part. So that's my question.
Okay. Yeah, thank you. That's all.
I
Thank you very
will
much.
follow up. I'll just remind you, Dulasi, what I was mentioning earlier. I mean,
Yeah.
the P4Lang tutorials repository does use integrate BMV2 and Mininet, and you can simulate, 3 or there's examples with 3 or 4 switches, simulated switches in those. And again, it's really big downside is when you get to high packet rates and queues building up, it is nowhere near, it is often very far off of what a real hardware switch, how queues would build up and drain in terms of the times that packets are transmitted between switches. There is an exercise that, it says, take this virtual Ethernet link between these two switches and limit it to 10 megabits per second so the queue builds up. But if you look over time at the time pattern of queues building up and draining, it's very unlike a real physical switch would give you. And I
Okay.
think that's what ns-3, that's what this P4sim work I think will do much better, is it will more accurately model the time pattern of the way the queues build up and drain over time, more
Okay.
like a real
Yeah.
hardware switch would.
Yeah. Yeah. Thank you very much. Yeah.
Yeah. And I guess another comment on my understanding is, so Mingyu showed one example where I think he had a single P4sim instance simulating 45 switches and I've forgotten,
This
54
one.
hosts, something like that. Yeah. So I think this is a single P4sim instance, I guess, in your, like you start up one program and it starts up all these switches and hosts at once.
Yes. Yes.
And if you want to get the accurate simulated time of packets flowing between these different switches, they really should be in a single P4sim instance, not 54 different P4sim instances. For example, you shouldn't do one per switch if you want the correct simulated times between the switches.
Yes. This testing is using just a single switch. So for this testing, I just want to show that we have automatic generate network, a script to help you to generates the flow table entrance. Because if you write one by one, will be too complex to build the network. Because you need to think about the tables, actions, and also the IP and the array settings in ns-3, and also the P4. That makes very complex.
Okay.
Yeah, this is because when I testing like with that, I also struggling with the different IP or MAC settings in the different host and how to do that. So I just write a automatic script for help doing that, something like that.
Okay. Okay. Yeah. Thank you very much.
Yeah. This test is basically one switch per host.
Any other questions folks have? Either put it in chat, or you can, if you want to raise your hand or unmute yourself and ask, please go ahead. Okay. Thank you very much, Mingyu. Interesting presentation. like I say, I'm sorry I haven't tried out the software yet, but I will definitely, in the future, when somebody tries out a mini-net simulation with multiple VMV2 switches and asks why the queuing behavior is wrong, I will point them at your work, definitely, and say, and recommend they try it out, because this is definitely filling a gap for multiple people that have over the years tried to misuse Mininet, or they were hoping Mininet with BMV2 would do what P4sim does, but they were disappointed, and I had no other answer to give them before. So now I've got something to some work to point them at that hopefully will achieve the behavior they want. So that's great to have. I think that's all for today. Again, thank you, Mingyu, and we hope to. So recording should be available later, and please check out the P4.org website for the events section for other future upcoming P4 Developer Days presentations, which have already been scheduled and coming up.